AQA AS Level Chemistry, May 2017, Paper 1 walkthrough. Question 1 is a question about atomic structure. Atomic structure is one of those topics where it is so fundamental to A Level Chemistry. And, if you, it's always like 9 times out of 10 it's going to pop up. Obviously, if it's going to come up as, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9 marks for atomic structure. It's very, very important topic. The first thing says, write the full electron configuration for Cl- and Fe2+. Now, Cl-, so it's just going to be that, and you need to know all the 1s2, 2s2, 2p6 and all of that. And because you've got a minus charge, you need to add an extra electron. And Fe2+, you've got 2 plus charge, so you need to minus 2 electrons. Once you've done that and you're very confident with the 1s2, 2s2, 2p6 and doing that for the electron configuration should be pretty easy. Write an equation for the third ionization energy of manganese. So Mn2 plus gases are Mn3 plus gases plus E minus. State which elements magnesium, aluminium has a lower first ionization energy. This one's pretty difficult, right? It's going to be aluminium. And what I would do whenever I'm given a question, which one has a lower first ionization energy, just write down the electron configuration and then you can see the orbitals and the electrons. So aluminium, because its outer electrons in a 3p orbital, higher in energy, further away from the nucleus, so easier to remove. Question 1.4, give the symbol, include the mass number of the ion that would reach the detector first. I know it's nickel, so Ni. Electron impact ionization, so it's going to be positive charge, and thus the lowest mass, so 58. Calculate relative atomic mass of nickel in sample. Pretty nice question. 58 times by 61 plus 60 times by 29.1 plus 61 times by 9.9 divided by 100. Always double check it adds up to 100 and 58.9. Yeah, one decimal place. Write an equation for the reaction with the enthalpy change equal to the enthalpy of formation for iron 3 oxide. So enthalpy of formation, so that's what I'm forming. I'm forming iron 3 oxide, so Fe2O3 solid. So how do I form it? Well, 2 Fe solid plus 3 over 2 O2 gaseous. Uses data and equation to calculate value for standard enthalpy of combustion. Now I can either draw a cycle, or what I would do is just use the formula, enthalpy of products minus enthalpy of reactants. And I know delta H is minus 19, so minus 19 equals enthalpy of products, 3 CO2, so 3Y, minus enthalpy of reactants, minus 8 to 2, plus carbon monoxide, minus 111, but I've got 3 moles, so minus 333. 3Y equals minus 1174, Y equals minus 391, therefore standard enthalpy of formation for carbon dioxide is minus 391 kilojoules moles per minus 1. Use the data from table 3 to calculate bond enthalpy. Bond enthalpy, energy required to break bonds minus energy released when new bonds are made. Energy required to break bonds. So I've got this. So I need to break this. So that's plus 944. Plus this. Well, that's hydrogen to 2 hydrogens, 4 through 6. But I've got 3 H2 moles. 3 moles of H2. So I need to times this by 3. Minus energy released when new bonds are formed minus 92, and because I'm minus 92, it's going to become a positive 92, and then you get plus 391 as the bond enthalpy for NH in ammonia, because remember that would give you for 6 NH, and then you divide it by 6. Give one reason why the bond enthalpy you calculate is different from the mean bond enthalpy according to data book value. Data book value is derived from a number of different compounds. Data book value is derived from a number of different compounds. Data book value is derived from a number of different compounds. Show by calculation which reactant is excess, and it gives me the information. So first thing is first, find out the moles zinc sulfate. 50 divided by 1000 times by 1. Moles is concentration volume. Find out moles magnesium. 2.08 divided by mR, 24.3. I can clearly see magnesium is in excess. Then it says calculate experimental value for enthalpy reaction. Q equals MC delta T. M is mass of water. C 4.18 delta T. 61.2 minus 23.9. Change in temperature is 37.3. But then I want my answer kilojoules moles per minus 1, so I divide by 1000, so 7.796. And the moles Well, it's not going to be the moles of magnesium. That's the thing I would fall for as well. Because why would it ask me to find out the reactant moles, reactant which was in excess, those moles, magnesium, and then not using here? Yeah, you don't use those moles, the moles of magnesium. You use the moles of zinc sulfate because that's not an excess. So 0.05, you get minus 156 kilojoules multiplied by minus 1. Don't fall for that trick. You obviously, because I found out the moles of this, I'm going to use that moles. No, use the other one because that's not an excess. So just one most likely reason for large difference between students' experimental value and databook value, heat loss. Suggest how student method analysis results could be improved to determine a more accurate value for the enthalpy of reaction. So this is obviously going to be the calorimetry and the graph and the accurate temperature change. So stage 1, improve insulation, insulate beaker / use a lid / use a polystyrene cup to reduce heat loss. Stage 2, improve temperature readings, improve temperature recording, record temperature for a suitable time before adding the metal to establish an accurate initial temperature. Stage 3, improve analysis of results, extrapolate the cooling back to point of addition to establish a theoretical maximum temperature / temperature change. Just in terms of X amount of moles of R in equilibrium mixture. So I know X moles of P had reacted at equilibrium, and I can see that's 1 to 2 mole ratio, so it's just going to be 2x. Calculate value for equilibrium concentration in moles per minus cube of R. Now this one I find particularly difficult, really. I've done this a couple of times, but it's the idea of square root and obviously X involving algebra. So if I construct the Kc expression, products over reactants, right? And I know the amount of moles of each in P and Q are equilibrium 1 minus X. So it's going to be 1 minus X squared, because 2 of them. R is 2X. I just found out in the first part, so 2X squared. And Kc is 3.6. Then what I do is I square root both sides. The squares cancel out. I've got square root 3.6. Times by 1 minus X. Square root 3.6 minus root 3.6X equals 2X. Rearrange it, you get X is 0.49, and then the final part that's really tricky as well. I want R, which is 2X, not X, so then I substitute that in, so 2 times by 0.49, 0.97. I'm just showing you that, equilibrium constant or equal KP, KC, they can ask you questions involving algebra, and you need to be prepared for that. Question 5, question about intermolecular forces. Give the meaning of the term electronegativity. The power of an atom to attract a pair of electrons in a covalent bond. Simple one-marker definition. Power of an atom to attract a pair of electrons in a covalent bond. Explain how permanent dipole forces arise between hydrogen chloride molecules. Difference in electronegativity leads to bond polarity. Dipoles don't cancel out, therefore the molecule has an overall permanent dipole. Attraction between delta positive of one molecule and delta negative of another. Difference in electronegativity leads to bond polarity. Dipoles don't cancel out, the molecule has an overall permanent dipole. Attraction between delta positive of one molecule and delta negative of another. And they could ask you for this in any question. Explain how permanent dipole force arises between X molecules, whatever molecules. And those 3 key points or 4 are exactly the same, so I would memorize that. Complete table for naming the shape of each molecule. So SiH4 tetrahedral, pH3 pyramidal, BeCl2 linear, CH3Cl tetrahedral. Now if it has a permanent dipole, well SiH4 is going to be completely symmetrical, so dipoles will cancel out. Remember, in order for permanent dipole force to arise, difference electronegativity is bond polarity. Dipoles don't cancel out, so therefore the molecule has an overall permanent dipole. In this case, the dipoles will cancel out. pH3 dipoles won't cancel out, so we'll have permanent dipole. BeCl2 is linear, dipoles will cancel out. CH3Cl, but dipoles won't cancel out, molecule will have a permanent dipole. Balance the equations for balance the equation for 2 stages process. It's an equation, it's a pretty tricky one, but yeah, it's 4 CuFeS2 plus 9.5 O2 plus 4 SiO2 plus 7 SO2 plus 4 FeSiO3 2 Cu2O 6 Cu. I guess the most trickiest part for this is understanding you don't have to fill in all these gaps. You can leave some of them empty. It just says balance the equation. Suggest 2 reasons why sulfur dioxide byproduct is removed from exhaust gases. It prevents acid rain, aka which causes damages to buildings. The second reason is that it's toxic and it causes breathing problems. Calculate mass in tons of rock you need to produce enough copper wire for passenger jet. So find the moles of copper, mass over mR. I need mass in grams. I got the mass in kilograms, but that's no good. I want it in grams, so times by 1,000 divided by mR, 63.5. I get the moles of that. Then I can find out the mass of CuFeS2 by doing number of moles times by 183.5, the mR. Then I get the mass in grams. Then I can work out the mass of the ore. 1.17 times by 10 to the power 7 times by 1 contains this much of this by mass, so 100 divided by 1.25, 936 tons. Calculate percentage of atom economy for production of copper by this process. mR of desired products over mR or reactants times by 100. And the one key, very important thing is that we need to include all the moles when we're working out the mR. So in this case, I've got 2 Cu, so it's going to be 2 times by the mR of copper. In this case, all reactants. So 2 CuOs, 2 bracket 63.5 plus 16 plus 12 times by 100, and that's obviously 171 total mR of all reactants and 74.3%. Just remember, percentage atom economy, you have to include the moles when you're working it out to work out the mR. Suggest the identity of the group 2 metal ion present in solution Y. Ba2 plus is a white precipitate forms of sulfuric acid, and therefore to form barium sulfate, Ba2 plus A equals plus SO4 2 minus A equals to form BaSO4 solid. Suggest the identity of the negative ion present in solution Y. OH minus. Anytime I ask you for negative ion, this is usually probably going to always be OH minus anyway. Mg2 plus A equals plus 2 OH minus A equals to form Mg bracket OH squared solid. Give the oxidation state of nitrogen following species.